control, structure them all together. All right, so essentially then for these you are actually start doing refinement and bettering your design, right? So compare these two designs. Would this work? Would this work? Actually, both of them will work. Both of them will be able to result in implementation which can drive that elevator. However, which one is better? Okay, I mean likely this one will be better. Right? Better means what? Better efficiency, better code quality, better readability, better maintainability, and all these nice features to have. Right? So, so if you look at NBA, right? You can draft LeBron James. Oh, everything's great, right? Better design, everything, right? And you can draft Damian Lillard. Good enough. I mean, he can play and everything, right? Or you can draft the backup of backup of backup, right? I mean, that could work too, right? So it's all. So in that case, they can all ball pretty well and much better than we are, right? But so which one is better version? Oh, I mean, you have some better version. Then this better version will actually give you better features, readability, maintainability, right? Better, more compactness in your coding and everything. But that's not fundamental, okay? The fundamental thing is, if you can come to this design, you can get an implementation done. All right? That's why this is, again, this is 300. All the 300 and above classes are basically introducing optimizations. Make you do the job better. But these things are not fundamental in terms of, okay, if you don't have that information, yeah, you cannot do the job. No, it's just, that just make your job, do the job better. But this is actually being able to come to identify the classes, have the design, that's more fundamental. Because eventually, in our discipline, we basically all boil down to get that code written. This is a way to get, at least I'm going to get some code written, no matter what, right? Is it optimized? Maybe not. Maybe somebody will come to this design better, better with better design and say, okay, eventually make this whole system a little bit more structured. But hey, that only comes with more experience, seeing more design, seeing other people's design, and then you know, oh, actually there's a better way to do this, right? But first you need a way to do this. All right, CRC card, we'll talk about that later, and then to make sure that you capture all the behavior, that dynamic behavior you have in that spec. This is your friend, called state chart, also called state machine. We actually, ourselves, is a biological state machine, ourselves. Okay? So let's look at that elevator actually sitting there. It's probably running right now, right? So this is essentially by and large how it works. So what this means is actually describing the behavior of that machine. That's why this is called a state machine, right? So this state machine starts, so okay, once you start plugging into electricity, and get it all initialized, now we're ready to go, right? Then it's waiting for something to happen. If nothing happens, I'm just going to stay there. Okay? Very simple. That's how the computer, if you just put your computer there, certainly a computer is a little bit smarter than that, it will shut down itself and probably to preserve battery. But if you disable, that's just a nice optimization to have, okay? It's not a part of your fundamental functionality. Your fundamental functionality for the computer is sitting there waiting for an instruction. Just like that elevator edge is there to basically waiting for event to happen. If something happened, I'm going to do something more, and come back and waiting for more new things to happen. So this essentially captured how your system actually will be functioning. CRC card basically is to capture, okay, now I'm going to assign responsibility according to this dynamic behavior, state machine, to each object, to each class. Object of each class. What are the responsibility and what the other class is talking to? This is basically for you to capture the information of each class. CRC card eventually actually translate into our object definition. This is essentially very close to our object definition. We are step by step going to code. See, we're step by step going to code. At this stage, I already have the name of that class, and I'm trying to figure out what attributes and what methods should be on this class. Once you have the attributes and a method defined on the class, then we are jumping into implementing linked list. Then, boom. You know what? My job stops right here, right there. Color font should have already taught you how to deal with those, the rest. Okay? That's essentially how we hand over teaching responsibility as well. All right? So essentially, we are slowly basically go for English tags, identify the use cases, going to classes which are going to implement those use cases. Once we jump from, that's why use cases are looking at the system from outside. Once we get into high-level design, when we talk about classes, then we are really talking about code. We are really making the transition into code, right? Here we, at least we're going to have the name of the class, and gradually we're going to flesh this out as the method and attributes of our class. Once you flesh out a method and attribute definition, your design is done. You are actually going to implementation. Okay? That is essentially our transition. So how you get to this point, if you don't have anything else that's working, your verb analysis will come to your rescue. That's why I mentioned this many times. Computer science software development at its core is to map your life skill you already have. Organize them in some way of so-called software engineering, so you can translate English specification into code. That's your job. Okay? Unglorified version of software engineering is literally teach you how to use your grade school, high school, and elementary school skill, middle school skill, and then you can translate English spec into software code, Java, Python, C code, C++, what have you, in a basic way. Then other things are all your optimization, right? How to do better in security, how to do better in network protocol, how to do better in machine learning, how to do better in database. That's a plus to have, okay? Not fundamental. All right, CRC card basically assigns the responsibility to each classes. So essentially, if you say send a message, this is typical object-oriented programming. Object-oriented programming is basically, if I want somebody to do something, I'm sending a message. I'm going to send a message to that guy. If I send a message, it means what? I'm not implementing that functionality. I'm calling on somebody else to do it. If not sending a message, which means that I'm going to do it. Right? Then this is where your development team will sit together and have a heated discussion. Right? Should you do this? Should I do that? Which one should you what? Right? I don't care, actually. If you made the wrong decision there, you're going to have a bad design. But you are still going to come with a design. I can check to make sure that are you going to realize all the functionality or not, right? Because I'm apply the same approach as I apply to your requirement document, which is coverage. I'm just going to, as a check, 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 have you covered all my functionality? Yes, you go back, you implement maybe a bad design, but hey, it's a design, okay? However, if you don't check, well, you may have a design that's not actually implementing all the necessary functionality. This is where, okay, everybody sit in the same room and decide who should do what. Okay, this class should do this. Maybe I'm the code owner of this class. Either I like to do more work, so I'm going to say, I want to do more, right? I want more messages coming to me, right? Or I'm lazy, I'm just don't want to do more, I'm just going to push all the functionality to somebody else, right? I'm going to send messages. Okay, that is actually a negotiation about whether we have come to a better design or bad design. How to tell if it's a good design or bad design? Well, certainly eventually we'll use all the criteria like readability, performance, efficiency, and all these things to decide, right? But once we decide, human beings smart, we're not going to make the same mistake twice, so we're going to put those things in so-called templates. Patterns, that is so-called design patterns. Okay, you have done this before very successfully, which means that it works. If I'm coming to this domain first, I better not creating this thing anew myself. I'm just going to look at your pattern and say, I understand, I'm going to apply. That is called design patterns. Right? We have a class called design patterns. That is design patterns. It's not complicated. Basically say, she done this before, very effectively, very useful, so now you don't have to reinvent the wheel again, you just learn how she did it and you apply that next time. That is pattern-based software development, right? I have seen this before, not done by me, but I'm okay, I'm just going to apply the same pattern. That's how we scale, right? How we pass knowledge around so we don't have to do everything every time from ground up ourselves. Okay? Every time when you call on C library or Java library, have you thought about redo those library yourself? How many of you are really interested in redo the Java library from ground up? That is called pattern-based approach. This library is already there. This linked list is already there. Why my instructor asked me to implement the linked list? Right? Same thing. Here you're doing this for practice, but when you go to work, yeah, if there is linked list implementation in Java library, probably that's a higher, more optimized, higher quality piece of code I can reuse, right? Only when you find, this one doesn't give me all the functionality. I need to make something by on my own. That is for later, okay, guys? At the beginning, it's really hard for you to come up with a much better implementation than all the library ones. Eventually, you may be there, but hey, at the beginning, use whatever available right now from a standard library, if possible. Okay? All right, so in that case, you can keep refining this class diagram. However, this is optimization. This is not fundamental. Any of the previous diagram we can go just run and implement. The real trick, the real thing is whether it's going to be high quality, quote unquote, in all kinds of metrics we can use. But hey, if you have the design, you can already implement something. That is also our requirement. You need to get a requirement done, a high-level design done, a implementation done. So when I need you to get it done, okay? I'm not looking for the best chat app in the world. I'm not going to use yours, okay? I'm going to use WeChat to talk to my mom, right? Not your chat, right? But hey, it's important for you to demonstrate you can do this from beginning to end in this app, okay? May not be the best app available, may not be the most optimized. You need to get one complete program done. You have to show me that. You may say, I already can do that. Yeah, you show me, you got the credit. Simple. If you cannot show me that, Okay, you have to learn to get it done. All right, so this is the normal situation. You basically you add more information to it. Again, you may say, oh, when should I stop? Man, this is too much. When should I stop? Again, it's very simple. If I detach this document from you, make it anonymous, remove all the identification information, I pass that document to another classmate of yours, and he or she can continue to next stage called high-level design or analysis. Your requirement document is fine. If she or he can actually take your high-level design and run to implement go to the detailed design, that'll be fine. Okay. For a system as simple as it is of our system, you should be able to do that. Basically, your design, your requirement should be self-explanatory and self-contained. The information is consumed by human being. The real judgment can actually be consumed by another human being of same technical level or not. You guys are by and large on the same technical level. Okay. One thing you can try is actually, I don't mind for you to share your document with him and say, can you understand? Can you understand? Do you think I covered them all? Very, very simple. You may be confident enough and say, yeah, I did it. I don't need to show to her. No need. Fine. If you want to show to another classmate and say, can you understand this? It's actually a pretty good way to validate. All right. I mean, you can keep going, keep going. These are optimizations. Right? This decentralized computer architecture and all these more and more into refined implementation. So this is just, if we're doing refinement like this, we are making the design better in terms of all the other features we are looking for: reusability, modularity, efficiency, and all these things. Right? We're looking for that. That's why we're refining, and also to make to make the structure better. But fundamentally, I mean, this kind of refinement, it really depends on what you are trying to do, right? So the size of the project we're looking at, you don't really need so many refinements, right? So refinement is really to make it better. But you have to come to, so you have to know when to stop, right? When to stop means that you actually have to come to the point when you give this to another person, he or she can actually go implement this. All right, so this is, so then you can look at interface and interface class. So interface class, I mean, interface class for the elevator is pretty straightforward. Buttons as input, and a few LED display, that's all. No, nothing fancy for elevator. Right? So for computation, basically that's really here in this diagram. That's the computation going on. Once the button got pushed, what's going to happen? That is actually your computation, your control. Okay? This graph showed you statically what information is being kept in your system. The two different sides of coin. One is class diagram, showing you the permanent information in your system. The other is your state chart, basically showing you what action is happening in your system. Okay? This is your high-level design, pretty much. Minimum. Your class diagram, your state machine. One capture the static structure, the other capture the dynamic structure. What are so essentially these are the information holder. Actually, where you put your information, the data, and also the operations. Where those operations come from? From this chart. Okay? These are operations. Somebody has to bear that information, this action. Somebody has to bear that information. Then you have to basically assign these to one of the class. We'll talk about how we assign that later. Okay? Basically, this is two sets of information. Minimum you need to have. Statically, this is the number of components I have. Dynamically, this is the action I had to finish. Okay? Make sense? How do we come to here? This is by, actually, minimum by our verb and noun analysis. These are all the verbs going on right here. Those are noun we have in the description. This shows you how much information English text can actually capture. A lot of information. If you make them structured, easier for people to understand, either for machine and people to understand, you can see that actually a lot of information. So human being is very capable AI machine in the sense. I mean, we can process that information easily. But for machine to be able to structure this information, you can see how much work is being done. That's why human beings still, in terms of reasoning, much superior than AI today. AI is right now very good at pattern matching. You're not going to beat AI in pattern matching. That's why we lost on chess, we lost on Go, we lost on those games. I mean, play video game against computer is hopeless, right? So that's why you lost your money playing video game, right? So no matter what kind of thing you do pay for, and eventually you will lose to the machine, because the